So today we are looking at phase diagrams in a different way. There's nothing in here that is new. We've been doing these, but just haven't looked at it this way. So the first thing I want you to see here is that we have the three phases of matter. Plasma is not normally on one of these. So I have two things on my X and Y axis. I have temperature and I have pressure. So what this graph is showing us is that we can change phases depending on temperature, which we've known, and that's what we have been working on. But we can also change the phases depending on pressure, or a combination of these two. So, like I said in class today, where this is applicable is like in factories and places that mass produce things where you have this huge machinery, and let's say, for example, I have a liquid that I need to turn into a gas so that I can make a product. Well, instead of just heating it up, liquid to gas, like we would normally think, there's also another way to do that. If I had a machine that actually decreased the pressure of a liquid, I could just within that machine, just by decreasing the pressure at the same temperature, I could make that liquid become a gas. So this is where you see that real life application of where something like this may be the basis. So this is really just graph reading. So we look here, we have a pressure and we have temperature. This is in bars of pressure. Sometimes that's an atmosphere of pressure. This here is in Kelvin. Sometimes it will be in Celsius. So most of the time Celsius, but sometimes Kelvin. Kelvin's just a different temperature scale. So you notice here what you see is pretty much a Y shape. And every time you see one of these graphs, you should be able to identify some sort of shape in the center of the graph of the three lines that makes almost this Y shape. And solid is always going to be on this side, liquid is always going to be in the middle, and gas is always going to be over here. So solid, liquid, gas, even though they are not labeled most of the time. But that's the areas that you find them. So your temperature and your pressure act like ordered pairs. So for example, if I had 100 in temperature, 100 Kelvin, and 1 bar of pressure, if I were to plot that point, it would be somewhere in here. So that means I would be dealing with a solid at that point in time. At this temperature and this pressure, I would be dealing with a solid. If I increase that temperature to maybe 400 and the pressure to 10, I could take that same substance and now it's in the liquid phase. 400, 10 bars of pressure, I have a liquid phase. Over here, if I was at 400 and 0.1 pressures, like an ordered pair, I would have a gas. So those are the three ways that it can be. So this other thing is you've got these lines. So these lines are phase change lines. So if it were to land on the line right here, let's say your point landed here, whatever that was, this is going to end up being both phases at the same time. It will be kind of in between. That's your slushy point. You're sometimes a solid, sometimes a liquid, right? It's that kind of a little bit of both. So what's happening here is this line is your melting freezing line. So if I cross the line this direction by changing pressure or temperature, then my substance would be melting. If I cross the line in this direction, changing pressure or temperature, my substance would be freezing. So there's your melting freezing line. And the melting and freezing temperature is the same at this pressure at this case. So your melting and freezing point will always be the same. Looking here, we go from a liquid to a gas. So here's my liquid gas line in between there. So going from a liquid to a gas, if I cross this line with my substance by changing temperature and pressure, this substance would be then going through vaporization. If I go the opposite direction and go from a gas back to a liquid by changing temperature or pressure, this would be going through condensation. Okay. So down here at the bottom, you can see underneath this point, there's another line, and that means that it's skipping over the liquid phase. It kind of cuts the liquid phase out. So this is going from a solid to a gas. So if I can change take my substance and change the temperature and pressure down here, I can make this substance actually sublimate. We're going through sublimation. going from a solid directly to a gas. And then I can do the opposite by changing temperature and pressure and make it go through, deposition. So deposition, so it's depositing back from a gas into a solid. So I can do both of those. So again, all of these lines are showing phase changes. Now there's a couple points on here that are points of importance. There's this point right here that is the triple point. And the triple point, it's up here at the top in your reading what the triple point is. But your triple point is where all three lines meet, and that also means where all three phases of matter can exist at the same time. So triple point, three lines are meeting here, and the three phases of matter can exist at the same temperature and pressure, very, very close to each other. There's one other point, is this point up here, and this point up here is called the critical point. And that means that critical, after that point, if it gets higher in pressure, or in this case higher in temperature, it goes up into here, what I call no man's land, so up in here. If it gets up in here, it becomes a supercritical fluid. And at that specific temperature and pressure, which is in this case very, very high in both cases, it becomes indistinguishable between a liquid and a gas, meaning you can't tell the difference. Okay, so that's your critical point, and that makes a supercritical fluid. So that's the basics of how to read one of these phase diagrams, and we're going to do some practice with that as well in the class. So I'm going to go through the practice with you here. These go on page 32 and 33. So I put that on page 32, and this is on page 33. They don't have to be in that order. You can put one on 32, one 33, doesn't matter there. So we did this one together in class, and I know this is hard to see, but you should have one of these so you can follow along with. It's hard to see on camera, but it says which section represents the solid phase. Well, the solid phase, remember, here's my Y, and if we can kind of see and zero in on that Y, here's the Y shape that we were looking at. So my A over here is going to be my solid phase, so everything is in this part would be a solid. The C phase would be liquid, so anything that's inside that Y is going to be my liquid. And then the represents the gas phase is everything that is in B. So that's down here. And then it says, where's the triple point? So my triple point is where all three lines meet, so that's right here at point D. And it says, in your own words, what's the definition of the triple point? In my own words, that is where the three phases all exist at that temperature and pressure. So three phases all exist. All right, this says, what is the substance's normal melting point at 1 atmosphere of pressure? So at 1 atmosphere of pressure, I want to know the melting point. So that's going to be a temperature, what they're asking for there. So if I go back up to my graph and I find, and this one is easy to see because it has the dotted lines, but if you need to, sometimes you can take a ruler. So I'm looking at 1 atmosphere pressure. I come over and I put a dot right there. At that dot, this is my melting freezing line. So then I just follow that dot down and I look at the temperature, and I have 60 degrees. So my normal melting point is 60 degrees Celsius. Now it's asking for the normal boiling point at 1 atmosphere of pressure. So I'm going to go up to my graph. I'm going to do the same thing. I'm going to look at 1 atmosphere of pressure. Not going to stop there because that's the melting freezing line. I'm going to go on over to my vaporization, because where my go from a liquid to a gas, that's my boiling point. So then I go down and I look at my temperature that coincides with that, and I get 100 degrees Celsius. Now this one says, above what temperature is it impossible to liquefy the substance no matter what the pressure? So impossible to liquefy means you cannot put this into a liquid. So this is really telling me when is it becoming a supercritical fluid. So if I look up here, this is my critical point. So I want to know at what temperature, if I go past this line, this point right here, it cannot go back into here because the temperature is too high. So anything above or on this side of the line can never, ever, ever be a liquid again unless you reduce the temperature. So that critical point happens at 110 degrees Celsius. So my critical point, no matter the pressure, I can never put it into a liquid again, is 110 degrees Celsius. At what temperature and pressure do all these three phases coexist? So you're looking for your triple point. You're basically looking for your ordered pair. How would you find your triple point? So if I go to my graph, I find my triple point is at D. So my X coordinate there would be 45 degrees, and my Y coordinate would be 0.5 atms of pressure. So that's what I'm going to write in my blank. At 45 degrees Celsius and at 0.5 atmospheres of pressure, that is where my triple point is. So I can go backwards from that. If I look up here, I can say, okay, if I have 45 and 0.5, I should wind up at my triple point, same spot. So at constant temperature and pressure, what would cause this substance to change from a liquid to a solid phase? This one you have to really think about. So basically, if I go back up here at a constant temperature, I want to go from a liquid to a solid. What would I have to do? So I'm just going to plot a point and say, okay, if I've got a liquid, maybe right here, I'm going to put an X where my liquid is, somewhere in there. I need to make it cross this line. This is my melting freezing line. If I want to go from a liquid to a solid, I really want this thing to freeze. But we think, oh, we'll just take away thermal energy because that's what we've been talking about. But I can't. I need constant temperature. So I have a factory and I say, hey, I need this liquid to become a solid. I need a machine to do that, but you can't change the temperature. What are you going to do? So your engineering would know, well, I need to make a machine that is going to be able to pressurize this substance higher or lower. What am I wanting to do with this X? Well, I'm wanting to make it cross this line because it needs to go to a solid. So if I take this X and make it go across that line, then that means it's increasing. I need to increase my pressure quite a bit from maybe this is maybe 0.7 or so, 0.8, and I need to make it go past 1. So somewhere above 1, that would pressurize the substance, then it would become a solid at this given temperature. So there, what you would do is you would increase the pressure. And then the last thing is, what does sublimation mean? That means it goes from a solid to a gas. Now, what I'm going to do is I'm going to take pictures of the inside of the answers of these and post these on Google Classroom, but I would like for you to try the inside on your own. The inside has 6 here with the graph and 6 here with the graph. So you can try those on your own, and then I will post the picture with the answers that you can check back and self-check.